Hello. Let's take another example for recursion. In this example, we will try to find out the factorial of a number. So when we say factorial of a number, so let's say if it is n factorial, if we are going to calculate, which will be given by n multiplied by n minus 1 multiplied by n minus 2, and this multiplication process goes on till we reach 1. So that is our n factorial. So if we have to calculate 1 factorial, which is again just 1, because 1 into 1 only will be remaining, then 2 is 2 into 1, then factorial of 3 if we calculate, which is equal to 3 into 2 into 1, which is equal to 6. Factorial of 4, which is equal to 4 into 3 into 2 into 1, which is equal to again 24. So if you just observe here, what we are doing is we are multiplying for 2 factorial, multiplying 2 into 1, which is again a 1 factorial. And when we are going for 3 factorial, we are multiplying 3 with again 2 into 1, which is 2 factorial. Then for 4 factorial, if you just see, this is a 3 factorial. So when we are going to calculate a n factorial, we can actually do n into n minus 1 factorial. So this is what the formula we are applying to do the answer in shorthand. So this is one Python code which I have written. Again, n we are just assuming that greater than or equal to 0. So if any negative value of n is there, anyway factorial does not exist. So we can add the condition here. If n is less than 0, please enter a valid integer and it should be positive. So that condition we can add. So again, there is one term which is 0 factorial is given by 1, which is already given. So this is our base case which we are going to form. If n is entered as a 0, our code will return it as a 1. So our code will return, if n is equal to 0, it will return the value of 1. Else, so this term is becoming a base case now. And now this term, which will become a recursion. So now if you just see, when we are going to solve this problem for a factorial, let's again start with one example, and then we can see how we can just go with the stack. So now when we are going with n equal to 5, just I'll assume n equal to 5 now. So I have to calculate a factorial of 5. So now factorial of 5, when I call this function, this will return, once you enter the is n equal to 0, no, then what it will do, it will go here and it will return 5 multiplied by factorial of 4, right? So this is our first answer. So which is for n equal to 5, I am getting the answer 5 multiplied by factorial of 4. But I am not getting any clear answer. So again, what we are doing here, we are decreasing n by n minus 1. So again we are applying a recursion in decrease and conquer manner. So we are decreasing the value of n, we are starting from the highest value and then we are decreasing and lowering it to the base case value. So now when I am putting n equal to 4, because I have reduced it, so I have to calculate factorial of 4, which I will be again getting 4 multiplied by factorial of 3. So similar fashion, I will calculate n equal to 3, where I will be getting factorial of 3, which is equal to 3 into factorial of 2. Then I will write here factorial of 2, which is equal to 2 into factorial of 1, where n equal to 2 this case. Then n equal to 1 case, I will be getting factorial of 1, which is equal to 1 into factorial of 0. And when n becomes 0, we enter into our base case and I will be getting factorial of 0 equal to 1. So now when we got this factorial of 0 equal to 1, you are just going to back substitute this value here which is factorial of 1, I will be getting 1 into 1, that is again 1. Then factorial of 1, I will be putting value here, where I will be getting factorial of 2 as 2 into factorial of 1, which we got 1 here. See, this is 1, then here I will be getting 1 into 1, which is 1. Again here I will be getting 2 into 1 now, which will become 2. Then this factorial of 2 value will be substituted here, which is again 2 multiplied by 3. I will be getting 6 here. Then this factorial of 3 value will be substituted here, where you will be getting 4 into 6, 24. And this factorial of 4 will be substituted here, that is 24 into 5, which is equal to 120. So your answer will be 120 for the case of factorial of 5, right? So this is how the recursion work for factorial. So let's again do the same thing with respect to stack. Okay, so now let's assume we have a factorial of 5 called. When I call factorial of 5, it will return me 5 into factorial of 4, but I am not getting answer, so I have a stack which is empty now. So in this stack I will be putting the value of factorial of 5. So right now this is the top of the stack because it was an empty stack. Then I will be going to factorial of 4, which will be again 4 into factorial of 5 or 3. It is 3. So 4 into factorial of 3. So again this value is not clear answer. So I am again substituting that, pushing this value on the stack, which is a factorial of 4. So this is how the stack is getting updated every time when you push the value. Then you will calculate factorial of 3, which is equal to 3 into factorial of 2. And again you are getting here fact of 3 pushed over the stack. So I'll just go ahead and I'll push all the values. So factorial of 2 will be pushed later. Then I'll be pushing factorial of 1. So after that, after calculating factorial of 1, you will be getting 1 into factorial of 0. And now factorial of 0 is returning 1. So I will be getting factorial of 0 next step as 1. So now see, we got the factorial of 0 value, but still we have 5 more values to be calculated, right? So these all values have been pushed over the stack. So here you have applied the push operation and it has been pushed here. Then here you have applied push operation, this factorial 4 will be pushed. Same way here you have applied push operation, this will be again pushed over the stack. Now what we have to do, again we have to back substitute these values whatever we got, and we have to calculate the factorial of 5. So the recursion is actually initial, our problem was bigger problem where we had n equal to 5, and that we have decreased at each stage and we brought it to the base case. So this is the first method. Now again you have to resubstitute it and come back to the original. So now what we have, factorial of 0 is 1. So you will pop the stack. Now factorial of 1 is 1 into factorial of 0, which we found here as 1. So you can just write 1 into 1, which is equal to 1. So now this value is calculated. Then again pop the top of the stack. So factorial 1, this has been popped here. Now you will be popping factorial of 2. Okay, so that I will be taking here. So which is factorial of 2, which is equal to 2 into factorial of 1. So you will be getting again 2 into 1, which is equal to 2. Similar way, factorial of 3 you can do. Factorial of 3. So I will be just writing here. Okay. So again you do the pop operation over the stack. So this is internally done when you are actually returning function as function itself. Stack is a temporary memory storage thing. So you are just pushing that in the stack, and compiler only will do those operations for you. So it is again factorial of 3 will be 3 multiplied by fact of 2, which is equal to 3 into 2, which is equal to 6. Similar way, factorial of 4. Next pop operation again, you will be doing 4 into factorial of 3, which is equal to 4 into 6, that is 24, and the remaining pop operation is C. Factorial of 3, this one is popped out, then this one is popped out. Now factorial of 5 is actually top of the stack. So again I will be popping that top of the stack, and we will be getting factorial of 5, which is equal to 5 into factorial of 4, which is equal to 5 multiplied by 24, and answer is 120. So this is how your compiler in case of recursion works. So these two examples we have discussed, but if you want some other examples to be discussed, please tell us in comment. And the main thing which we have done, the phenomena which we have used is n multiplied by n factorial equal to n multiplied by n minus 1 factorial. This forms a recursion, and this is what the recursion phenomena we have discussed. So if you want any other examples which you have, please reply us in a comment box. We'll try to solve those things. Thank you.